Meet ETA Ensemble Traffic Agents powered by predictive AI. They sense when a crash is about to happen, alert drivers, and automatically coordinate towing, police, and EMS before impact.
Hi, my name is Randall DeBastiani, and I have a background in finance and computer science.
Hi, my name is Brad Hall, and I'm a senior full-stack software engineer and a technical lead.
Our team also includes Fatima Doyen, a PhD in computer science, as well as Jared McHugh, a Rust-focused CS student. We chose to tackle the traffic challenge, focusing on using machine learning to predict collisions and other traffic incidences 2 hours in a window in advance before they happen. Potential stakeholders and customers include small business operators of tow trucks and EMS vehicles, as well as government agencies and dispatch. In addition to heat maps and a digital twin, along with locations to place individual assets, we also powered it with 2 of our own bespoke models, one using the novel cutting-edge Mamba framework, which we enriched with additional data sets and real-time data, another using GRU, which allowed us to create fast multiple agents running inference on the Spark, and for the digital twin, and we created our own app as well to allow drivers to locate and go to optimal locations. Let's dive in. To predict collisions and traffic incidents, we trained our own bespoke model using a structured medallion architecture and scalable data ingestion pipeline going from bronze, silver, to gold, to tokenized, train, and inference. Bronze ingested both the traffic incidents dataset and the historic weather data over an overlapping period. Silver standardized the data to the same shape and tags. Gold, together with the tokenizer, sorted the data into collisions versus other incidents and enriched the data with time of day, session, and other features, along with an additional suite of look-back and traffic flow features that can be pulled to scale the feature set in the future. The tokenizer then takes all of these variables and columns and moves them into multidimensional vectors known as tensors. From there, we train our own model from scratch using the recently developed Mamba framework. For the training loop, we use binary cross-entropy as a measure of information which excels at event and no event classification and probabilities like traffic incidents. We validate accuracy and have a choice of thresholds for roll and precision. Roll being a measure of how true events are covered within the scope, and precision being a measure of exact forecast. We erred on the side of events, so safety assets would not miss collision. Here you can see the pipeline running from silver to gold. Epic 1 has started to train with each step, losses improving, over time dropping. As we continue on, you'll see the roll and precision metrics. We run all of this on the Spark, which gives us the ability to train and scale quickly. And it runs on a Blackwell system, which means that in the future, should we want to scale to larger clusters, it's the same systems that run on AWS and other cloud structures. We then run inference of our bespoke model on the Spark in a 5-minute projection loop that projects events for collisions and incidents 2 hours in advance to hotspots over the Austin approximately 30-mile radius grid using real-time weather and time feeds, projected onto a hexagonal grid bucketed to 4 miles across. We then have middleware calculate the optimal location to position towing and safety assets given the forecast hotspots, so that all spots are covered with a balanced probability of any individual towing or safety asset being the responder. Both output sets are pulled by the front end on the same loop for real-time prediction and intelligence. Here you can see that model running inference on a loop which powers the back end of the digital twin, the individual vehicles which run across the Austin grid. We also trained a second model. We made it simple and based it on some additional data that we used to enrich the overall data set. We were able to locate 15-minute interval radar station data for the city of Austin over 2024 and into 2025. We used that and bucketed every 15 minutes in a simple, fast structure using gated recurring units, and trained against a baseline to get a sense of how far above or below demand the traffic flow would be. And use that to power a digital twin that we ran on Sumo, mapping that demand to each of the individual nodes in the graph for the city of Austin's grid.
As you can see here, we're simulating Austin's traffic. This is done using Sumo open source software. Sumo stands for Simulation for Urban Mobility. This is an open source traffic modeling software that allows users to model traffic. As Randall explained, this is what's powering the back end and what is currently feeding data such that the front end can render these smaller icons that you can see are representations of vehicles. So our team trained a model on historic incidents to predict the optimal positioning of recovery vehicles within the city of Austin. What you see here is a map of Austin with a heat map consisting of both red and blue hotspots. Traffic incidents, hotspots for things such as road blockages, stalled vehicles, maybe an animal's in the road, those are represented by the blue clusters. Hotspots for collisions or where someone may need EMS or there's something that necessitates a first responder, that's going to be represented by the red clusters. The higher the intensity, the higher the probability that a traffic event will occur nearby. Our team was able to determine these hotspots based on our own inference model that was trained based on historic traffic data from the city of Austin. So what you see represented by these red and blue dots are the most recent traffic incidents reported from the City of Austin's Open Data API. So when a new red dot appears, you'll notice this red line. This is a first responder that is going to the nearest red dot. He's at his forward deployed location and he will make his way to the closest red dot that is to him, and a similar story for the blue dots as well. Our team also developed a mobile app which can be used by first responders to respond to traffic incidents as they occur. Some of the icons that you see here, such as the hazard symbols, are representative of real-time traffic incidents that have been reported by the Austin Traffic API.
Thanks for considering ETA.